Okay, so the rational zeros theorem helps us to figure out what possible solutions are going to be in order to figure out what all the solutions are going to be of a polynomial. So let's say they don't give us a graph. We know we're supposed to have 4 solutions. Well, this is the way we can narrow it down to fewer possibilities that we could try to plug in and use the remainder theorem to see if it actually would be a solution. So what we're going to do here is for the possible rational zeros, they're going to be in the form x equals plus or minus p over q. So p is going to be factors of the coefficient in your polynomial. So if your polynomial is in the correct order, so in descending order, your last number here, your coefficient, is going to be factors of that. And then q are going to be factors of the first number, so your leading coefficient with your highest exponent. Okay, so what do we mean by rational zeros? So these are just zeros that are rational numbers. So some examples of rational numbers. So any of your whole numbers are going to be rational numbers. So like x equals 1, x equals -2. And then your fractions. So x equals 3/2, x equals -4/3. Anything that you can write in as a fraction. So if you have 0.5, that will work because you can write it as 1/2. Okay, but if you have 0.1, 2, 3, 4, 5, 7, something that's not going to change into a fraction, that would not be a rational number. Alright, so what we're going to do for our procedure for finding our rational zeros, going to be to solve this problem, we're going to use this rational zeros theorem that we just talked about to find our possible candidates for our zeros. Then we're going to use the factor theorem that we talked about earlier, which is where you see if that remainder is 0. And then after that, we're going to use synthetic division to be able to figure out the next factor. And then once you have a quadratic left, you have to get it down to where it's a quadratic. You can either factor, or sometimes you'll have to use the quadratic formula. If you don't have a quadratic, you may have to repeat steps 1 through 4 to get to the quadratic. Steps 2 and 3, sometimes if you want to just use synthetic division to check the remainder, you can do that instead of using the factor theorem every time. So steps 2 and 3 we can combine sometimes. Okay, so here's how this is going to work. So for this one, I gave us a graph to go with. Sometimes you will not have a graph, but for this one we can reference a graph. So the first step said we're going to find our possible candidates using that rational zeros theorem. So to find our possible zeros, what you're going to do is it's going to be factors of the coefficient. So factors of 2 on top over factors of the number with the leading coefficient with the highest degree. And it does say it's plus or minus those factors. So, factors of 2. Only factors of 2 are going to be 1 and 2. So you could have plus or minus 1 and plus or minus 2. Factors of 3 would just be plus or minus 1 and plus or minus 3. So all the combinations here, if we do 1 divided by 1, that'll just be 1. 1 divided by 3, we have 1/3. And then 2 divided by 1 will give us 2. 2 divided by 3 will give us 2/3. And they all have the plus or minus. So these right here are our possible zeros. And they're the possible rational zeros. So what we're going to do is we're going to use this graph to kind of help us. So first off, this is to the 3rd power, so that's a 3rd degree. So when we finish, we should have 3 answers to this problem. Okay. So using this graph, you can tell it crosses the x-axis 3 times, which means 3 solutions. So what we want to do here is we want to use this graph to help us. So I see that this is x equals 1 is where it looks like it crosses. Well, 1 is one of my possible zeros. So we're going to check. Now, this time I'm going to check using that factor theorem. I'm going to plug in 1 to our equation. But other parts you may get where you just use synthetic division to check. So however you can check and see what the remainder is, that's what you're going to do. So if you plug in that 1 there, that does give you 0. So remember, if the remainder is 0, that tells you that it is a factor. In other words, that x equals 1 is going to be a solution. So x equals 1 is one of our answers. We have to have 3 answers because it's to the 3rd power. So what we're going to do next for step 3, remember it said to do synthetic division. So we're going to do synthetic division using that 1. And remember, you just make sure they're in order, but you just put the coefficients. And bring down our first term, multiply, and multiply. You see how we get the remainder of 0? So this step right here and the step, we just did the same thing. So if you want to skip this step and just do synthetic division, that's perfectly fine. You're checking the same thing. Alright, so we need to see what we have left. So because we started out with 3x to the 3rd, that means this one has to be squared. So this is 3x squared plus 7x plus 2. Okay, you need to make sure this is a quadratic before you do anything else. So it is a quadratic, this is squared. So you can either factor or do quadratic formula. I'm going to try to factor. So if I do 3 times 2 is 6, 2 things that multiply to 6 and add to 7. Bring down our first term. Bring down our last term. Grouping. So our 2 factors are x plus 2 and 3x plus 1. So now we're just going to solve those factors. So x plus 2, set it equal to 0, so we get x equals negative 2. 3x plus 1, set it equal to 0, and that'll give us x equals negative 1/3. Okay, remember we already had x equals 1 as an answer. So now we have 3 answers. So we're going to check a couple of things. First, we're going to check to see if these were all possible answers. So negative 2 was a possible answer. Negative 1/3 was a possible answer. 1 was a possible answer. And then you're going to check your graph and see, okay, is that where it crosses? It is. So those are our 3 answers for that. Okay, so we have one more problem, very similar. So this one, we have 4, or to the 4th power, so we should end up with 4 solutions when we get finished. So we got to make sure we have 4 answers. If you look at the graph here, it does cross 4 times. So that means we are going to have 4 real solutions. Okay, so we're going to figure out our possible solutions first. So by that rational theorem, it's going to be factors of the last number here. So factors of 8 over factors of that leading coefficient 2. And we always have the plus or minus. So factors of 8, we have 1, 2, 4, and 8. And then factors of 2, we have 1 and 2. So if we write all of these out, we have a lot here. We have 1 over 1, so we just have 1. And we have 1/2. 2 over 1 is 2. 2 over 2 would be 1. We already have that. 4 over 1 is 4. 4 over 2 is 2. And then 8 over 1 is 8. And then 8 over 2 is 4. So these are all our possible ones. So because we have a graph here, we're going to use the graph to kind of guide us. So if we look at our graph, I see here this looks like 4. So I'm going to go ahead and just try synthetic division for the 4 instead of just plugging it in. You can do either way, but this will save us a step. So we're going to try synthetic division. Remember, we're just looking for a remainder of 0. Haha, so I do have a remainder of 0, so that works. So x equals 4 is going to be one of my answers. But if you look here, this is not going to end up being a quadratic. This is going to be a cubic. So we have to find another answer before I can do a quadratic formula. So looking back at the graph again, I see here kind of looks like negative 1/2. That looks like the closest. These look a little off. So I'm going to try negative 1/2. And what you can do here is you can just keep your synthetic division. You can keep going. You just keep adding onto it. And so we're just going to try this and see if it gives us a remainder of 0. And it does give us a remainder of 0. So that's another way of checking. You're just using synthetic division, but if you wanted to do the remainder theorem where you actually plug in, you can check it that way. So both of these are going to be a solution. So now we're left with a quadratic, 2x squared plus 0x minus 4. So this one you can't factor, so I'm going to use the quadratic formula. So a is 2, b is 0, c is negative 4. So remember, for quadratic, it's opposite of b, which would just be 0, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So we'll have plus or minus the square root of 32 over 4. 32 is the same thing as 16 times 2. So the square root of 16 is 4 with a 2 left underneath. And then you can reduce that to just plus or minus the square root of 2. Okay, so remember I was supposed to have 4 answers. So let's talk about them. So we have x equals 4. It's on our graph, and it was one of our possibilities, okay? X equals negative 1/2. It was on our graph, and it was one of our possibilities. Then we have x equals the square root of 2. Now the square root of 2 is not irrational, so that's why it didn't pop up here as possible. The thing about the square root of 2 is it's like 1 point something. Well, that looks about 1 point something, so there's that. Then we have x equals negative square root of 2. Once again, it's not rational. It's irrational, so it didn't pop up here. And that would be like negative 1 point something, which looks like it pops up over here. So, those are our 4 the real answers because they all showed up, but we have 2 that were rational and 2 that were irrational. But these possible zeros helped us to get started so we wouldn't have all these things to plug in. Sometimes you will not have a graph. If you don't have a graph, you might not have as many choices here, and you would just have to keep plugging in until you realize which one gives you a remainder of 0. So you will see some like that.